All right, let's talk about the two fundamental blueprints for pretty much all electronics. I'm talking about series and parallel circuits. Once you get these, everything else starts to click into place.
You ever just stop and think about this stuff we use every day? Your phone, your laptop, even the massive systems that keep our world running, they're all insanely complex. So how on earth are they built? Where do you even start?
Well, here's the secret. All of that mind-boggling complexity, it's all built on just two super simple foundational blueprints. If you can get your head around these two ideas, you've basically learned the fundamental language of electronics.
Okay, let's kick things off with blueprint number 1, the series circuit. And the main thing to remember here, it's all about one single path. That's it.
So what is a series connection? Well, the definition here is perfect. Components are joined end on end. The best way to picture it is like a chain of people holding hands in one long line. You're connected to the person in front and the person behind you, and that's the only connection.
And this image shows you exactly what I mean. See the current, that letter I, it's got one road and one road only. It has to flow through the first resistor, R1, then through R2, and then through R3, one right after the other. There are no forks in the road, no shortcuts, no other options.
And because there's only one path, series circuits have some really clear-cut rules. First off, the current is the same everywhere. The amount of electricity flowing through the first component is the exact same as the last. But the voltage is a different story. Each resistor kind of siphons off a little bit of the voltage. They all add up to the total, but each one has its own little drop. And the big one, the resistances just add up.
Which leads us to this beautifully simple formula. To get the total resistance, you literally just add them together, R1 plus R2 plus R3, whatever you've got in the line. It couldn't be more straightforward.
So here's the key takeaway. When you wire things up in series, your total resistance is always going to be bigger than your single biggest resistor. Makes sense, right? Every new resistor you add is just another obstacle in that one single path.
Okay, time for our second blueprint. And this one takes a completely different approach. This is the parallel circuit, and its whole philosophy is about choices, about creating multiple paths.
With a parallel connection, you're not doing that end-to-end thing anymore. Instead, you connect all the starting points of your components together, and then you connect all of their ending points together. What you're doing is creating a bunch of different branches for the electricity to flow through.
This diagram shows it perfectly. See how the main current, I, comes along and then hits a fork in the road. A portion of it goes down the R1 path, another chunk goes through R2, and the rest goes through R3. It's like a river splitting into 3 smaller streams. That's why we call parallel circuits current dividers.
So you can probably guess that the rules here are basically the complete opposite of a series circuit. In parallel, the voltage is exactly the same across every single branch. But the current? No. It splits up, and each branch gets a different amount depending on its resistance. Then, at the end, all those little branch currents join back together to equal the total current. Now, the formula for total resistance here, it looks a little more intimidating, I know. You're adding the reciprocals, that's 1 over R1 plus 1 over R2, and so on. But this bit of math is what leads to a really surprising and kind of counterintuitive result.
And here it is. This is the big one for parallel circuits. By adding more paths, you're actually making it easier for the electricity to flow. Think about it. More lanes on a highway means less traffic. So the total resistance of a parallel circuit is always less than even your smallest individual resistor. Wild, right?
Okay, we have our two blueprints. Let's put them side by side and really nail down the differences. This is the head-to-head showdown.
This table just lays it all out. Paths, series has one, parallel has many. Voltage, it gets divided up in series, but it's the same for everyone in parallel. And current, it's the exact opposite. Stays the same in series, but gets divided up in parallel. They're almost like perfect mirror images of each other.
And that leads to the ultimate bottom line. If you want to increase the total resistance in your circuit, you put things in series. If you need to decrease the total resistance, you use parallel. 2 different blueprints, 2 totally different jobs. So, why does any of this matter? Okay, let's zoom out a bit and connect these simple ideas back to the really complex tech all around us. Because here's the thing. Every single circuit board, in your phone, in a satellite, anywhere, is just a massive, intricate mix of these 2 basic patterns. Engineers use series and parallel connections like they're Lego bricks, snapping them together to build anything from a simple doorbell to a supercomputer.
So the next time you pick up any gadget, you'll know that deep down inside, it's all just following these two simple, elegant sets of rules. These blueprints are the foundation. So now that you know the rules,